Hello, welcome to Microsoft Build 2017. This is Mustafa Kasap. I'm here to present you Microsoft R Server development to deployment workflow with a quick demo. Microsoft R Server is an enterprise-scale server that you can host and manage your distributed and parallel workloads of R services that are running on Linux and Windows servers or clusters like Hadoop and Apache servers, Apache Spark. Actually, our server consists of several layers, which are based on top of core OpenR layer, which is compatible with existing or all R packages. And also, if you have a solution written in R and in a standard R language also, it's also compatible with all these source codes. We have several versions of our server, actually, the community and the commercial version. Community version is the open source one, and the commercial version has more advantage, like the better performance. And in this session, I will be mostly mentioning about R Server Windows, a standalone version of the R Server. Let's dive into the demo, and I will give a brief information about the demo solution that we will be developing, and what kind of data that we will be using, and the architecture of the R server cluster that we will be using. Actually, this simple project that we will be developing is an open optical character recognition. Even simpler than that, we will implement a solution to predict what is written inside a handwritten image, a digit image, to predict what is written inside that image. We will use this MNIST database, which is available publicly. It's an open database that consists of 70,000 handwritten digit images. And each of these images consists of 28 by 28 pixels. So how we will be representing this image as a row, single row inside the database. We just take each row of the image and side by side we put them and generate a single row that consists of 784 columns, and it will look like something on the screen as in the database. Each row of this database is, again, 784 columns, which are from V2 to V785. And the first column will be the label column, which shows us what is written as a digit inside that specific image. So generally, this is the data structure that we will be using. We will train a model, actually two different models, and I will show the difference between these two models. And we will use this model to deploy it as a web service, and at the end we will make some predictions using this web service over the R server. So let's have a look at the architecture that we will be using. You can deploy this solution actually on a cloud platform or a data center, on-prem data center servers. I will deploy two web nodes. Actually, they are virtual machines which are installed with R server standalone version and configured as a web node. And I will deploy 3 compute nodes. These numbers are just randomly selected, so it's not specific. You can deploy as much as you want depending on your workloads. And these two web and compute node clusters are connected to each other within the same virtual network. And the web nodes cluster will be our front end. So any request, web service request, or development deployment request coming into our system will be handled with the web nodes. So we will, because we have several web nodes, we may have several web nodes. You may prefer to put a load balancer in front of that, and any application or any client can access our web services through this load balancer, which will distribute the load to any of the available web nodes. Also, to synchronize the session states, our server, our session states, we will be using a database. In this specific sample, we will be using Microsoft SQL Server, but you can use PostgreSQL, SQLite, etc. These are configured inside the WebNodes configuration file, and also developers, authenticated developers especially, can access this system from any of the web node and develop their solution, deploy their solution through any IDE, RIDE, like the RStudio or Visual Studio with our tools installed. So this is the general architecture that we will be using. Let's switch back to our code and see how we will implement this optical character or optical digit recognition solution. First, I will load two different libraries, MRS Deploy and Microsoft ML libraries required for deploying the solution and develop our training models, our models. And afterwards, this is the actually single line of code that you can use to connect to a remote machine. Actually, this is the IP address of the web node, one of the web node. You can use any of them. I'm connecting to that web node. Now, from the command prompt, you can see there's a remote prefix in the command line, which means that everything that I will be writing through the command line will be executed at the remote machine, not on this machine. So, for example, if I say ls to see what kind of libraries, there's no variables. Let's create a simple variable. As you see in my global environment, there is nothing because this shows only the local one, but on the remote server, we have that variable available. So everything is running on the remote server. Even if I get the working directory, it is different than the one here on my local machine. So after opening this remote session, I will create a data folder in my current working directory and download the required training data, MNIST database, which is available publicly. You can download, and we will share also the links at the end of this presentation, this session. I'm downloading the files from this source and read this data into a dataset variable. Even you can get summary information about this dataset. Now I will split this data into two pieces: a training dataset and a test dataset. I will use the around 60,000 rows of this dataset to make a training, and the rest of the 10,000, in total 7,000, rest of the 10,000 for testing the system. So now I split the data. Now I will create my model. Here I generate a variable which is called model variable. Here it shows me the label and also the 784 column names, which are the dependents or depends the features, the pixel values that we will be using. So now what I can do is I will train a model with logistic regression. It will be running on the remote machine. Afterwards, I create a logistic regression model. As an alternative to show the differences, I will also develop a convolutional neural network model using this data. And this model will be, the training will be running on the GPU. You can omit this line of code if you want to run it on the CPU. So now I will be running the neural network training module. So I ran the logistic regression, by the way, second time, no problem. It will just take some extra time for that. But after this execution complete, I will have two different trained model that I will use for comparison. In the next line of the code, what I will do is I I will use the rest of the dataset, this 10K dataset, test dataset, to test these two models that I have trained, and then compare the results. Depending on using the prediction result, I will just compare these two models with some metrics like the precision, accuracy metrics to see which one is better than the other one. So I used 9 epoch to train my neural network, convolutional neural network model with 3 layers here. Afterwards, I will print out the results. Actually, it's on the 4th epoch, and at the 9th epoch it will finish. We need a few seconds more. Afterwards, I will print this accuracy precision values to see which one is better. And also, we will be plotting these metrics to make the visual evaluation of the model which is better than the other. So we are almost done on the 8th epoch. Now, I guess it will run the last one. Last epoch, yeah, now finished. So let's run the testing code. Yeah, we create the test results, compare the performance metrics, generate the performance metrics. Now we can report, print out these metrics. As you can see here, digit by digit, this is the recall, here is the precision, digit by digit. For example, for digit 8, which is much more complicated. For logistic regression, it is 0.8. For neural net, 0.95, which is better. So in general, neural net is the better for this solution, actually. So I will prefer the neural net model to publish it as a web service, and then I will consume it. Now what I will do is I will use the pause command, which is specific in the MRS deploy function. I will use it to switch back to the local session. Currently, as I said, I'm on the remote session. From the command line, you can see the remote prefix. If I type ls again, at this point, I will see several variables created actually on the remote machine. Now I will run the pause command. As you see, remote prefix is not there anymore. I'm in the local session. I don't have any variable in this local session, so I will copy paste the remote variables, the neural net model that I trained, and the variable names here. Now I have them on my local space. Then I will create a very simple function for making the prediction. This function will take a single image, a new image as a parameter, and it will make a prediction using the neural net model to predict what is written inside that image. So I define this function. Now I will publish a web service with name, any name you can write here. I wrote recognize digit, and you can give any version number here. And you say that the output of this web service schema is a single value with a numeric value. The output will be single numeric value. The input is, instead of writing a very long line of code here, I generate a input schema, 784 pixel values as a numeric value with a single line of code. And running this code, I will publish the web service. Currently, these web services are deployed on all the web nodes that you can see, that you can remember from our slide. They are deployed on the web nodes, and now it is ready, it's deployed. What you can do is the good side of the R server. Here you can generate the Swagger file out of this web service. I will write out into a file the Swagger file, Swagger information. Here you see the Swagger information from the web service that I have deployed. You can use this Swagger file to generate your own SDK over this web service that you can use in any programming language. So now let's test our system. I will create a BMP file which is 28 by 28 pixel. I just zoom in, so it seems a big image. Here I will write digit 8 and I will save it. Now it is in my working directory. I will load this new image and reformat this data into a single dimensional vector, and I will call my web service with this line of code to make a prediction. It is running, finished. And now I will print out what's the output. Yeah, as you see, it says digit 8. So you can, test it with some different values like 0, anything you want. I'm again running this code. As you see, it says digit 0. So you can delete also this web service as you wish. You can, if you want to develop a new version of that web service, if you are not satisfied with that version, you can develop the new version, alternatives with different models, with different approaches. So this is the end of the session. We try to show you how to develop and deploy a sample solution in the R server environment and scale, how you can scale these web services. Here are some links that you can use, refer to the code samples that we use that you can access from this link, and more information about operationalization of the R server. Thank you.